Hello everyone, and welcome to the Chapter 2, Sections 1 to 4 and 8 quiz practice. And what I'm going to be doing is going through every question in detail, and if you need specific questions more than others, you can skip ahead. And I've given you the final answers, so you should already know which ones that you need more than others. So definitely, let's get started, shall we? Okay, number 1. The goal is to translate each of these into an equation. But like some of your homework in the notes, we do not need to solve, we just want to set it up. So, the quotient of 25 and t. Let's stop there. Remember that quotient means divide. So, if I wanted to write the quotient of 25 and t, it really means 25 divided by t. And I prefer the fraction way, so I'm just going to write it as 25 over t. Plus 6. Is, remember, is always means equals, is the same as, is another way to say equals, twice t. When I hear twice t, I think 2 times as large. 2 times. So I'm thinking that means 2 times t plus 1. So if I wrote my answer more neatly without all of the colors, it would be 25 over t plus 6 equals 2t plus 1. And you could go through and solve that, but again, the goal is just to set it up here. The second example, 1/2 times the sum of x and 7 is equal to 13 subtracted from x. So this problem, the 1/2 is multiplying the entire sum of x and 7. So if I'm taking 1/2 times something, the sum of x and 7, remember sum really means addition, so x plus 7 could be written like this, representing sum, and I want to multiply all of this times 1/2. So I'm going to need parentheses there, and then it says that this is equal to 13 subtracted from x. So that means that 13 is subtracted after x exists, so x comes first, and I'm subtracting 13 from it. So my answer, again, just on the line, would be 1/2 times the entire sum of x plus 7 is equal to x minus 13. All right, onwards and upwards to just some good old equations. Number 3, my goal is to get a alone. I see a -9, so I would do the inverse and add 9 to both sides. Please just be careful with your signs, because now if I have -6 plus 9, that is not 15, that is not -15. -6 plus 9 is a positive 3. Number 4, my goal is to get g alone. -2 is currently multiplying it, so I would divide both sides by -2. And get that g is really equal to 12 over 2, because the two negatives, negative divided by negative is a positive. So this really ends up becoming a positive 6. Number 5, I'm sure as you all know, my absolute favorite question so far, 3/5 a equals 12. If I want to get rid of a multiplied 3/5, the quickest way, or one of the quickest ways, is to multiply by the reciprocal. And I know some of you in class have mentioned, could I multiply by 5 and then divide by 3? Absolutely. It's your choice, but I love the reciprocal. I know I did this right because the 5s and 3s cross out, so I'm left with a equals 12 over 1 times 5/3, which is the same as 12 times 5 is 60. 1 times 3 is 3. I love multiplying fractions because there's no common denominator. 60 divided by 3 is 20. So my answer is x equals 20. Number 6. This time, the y is not alone because of the -2/3. And negative really means subtract, so I'd have to add the 2/3 to both sides. Cross them out here. Y then is equal to -4/5 plus 2/3. Now, unlike the joys of number 5, where we saw the reciprocal, we're multiplying, we did not need a common denominator. However, over here on number 6, -4/5 plus 2/3, we do need a common denominator. So if I look at my denominators, the first number that 3 and 5 go into is 15. And so I look at this second fraction, it has the 3. So I need to multiply top and bottom by 5 over 5. And remember, this is really 1, which is why we can do that. And I'd multiply this fraction by 3 over 3, because this makes this 15. So I'd have y equals 3 times negative 4, negative 12 fifteenths, plus 2 times 5, 10 over 15. Negative 12 plus 10 is negative 2. Remember, you never change the denominator, or common denominator, it keeps the same. So my answer would be negative 2 fifteenths. Feel free to pause the video at any time and try the problems again if you're interested. Number 7, my goal is to get n alone. So the number on the same side of n that is not attached is the negative 7. So I'm going to inverse and add the 7 on both sides. So it had n over 5 equals 7 minus 4, which is 3. Then to get the 5 away from the n, I would multiply both sides by 5 because it's currently being divided. See you later. N equals 3 times 5, or positive 15. Now 7 and 8 are next to each other on purpose because 7, remember the negative 7 was moved first because it's not attached to the fraction. However, this time we have a giant fraction on this side. And so in class I mentioned that 3 is the reason the fraction exists and is the problem. So the first thing I want to do is multiply both sides by 3 so we can get rid of the fraction. Inverses cross out, so you're just left with x minus 4 equals 10 times 3, or 30. And now it's just lovely because we just need to add 4 to both sides. So we'd have x equals 34. And here it should say a, it should say x equals 34. Number 9, your goal is to get f alone. So to do that, we need to move the non-attached 17, and because it's positive, we're going to subtract it. So we have 3f equals 14 minus 17. Just be careful with your signs. Negative 3. Divide both sides by 3. Multiplication, division, or inverses. F would equal negative 1. Now we have variables on both sides. Unlike the previous examples, they were all on one side. So if I want to get my 9p over to the 4p, again, I know that there's multiple ways to do this problem, but I'm going to subtract 9p to get my variables on the left side. Cross out, 4 minus 9, negative 5p, plus 17 equals, don't forget that subtraction is really a negative, so you're left with negative 13 over here. Get p alone. Now we want to get rid of that 17. Cross those out. Negative 5p equals negative 13 minus 17. If you think about losing money, you are now negative $30 in debt, unfortunately. If you now divide both sides by negative 5, we would have p equals negative divided by negative, a positive 6. Number 11, it looks like we're back to having the variables all on one side. So this one is probably distribute and combine first. So if I distribute that negative 2 in, remember we always want to multiply before we add, and we cannot do anything in the parentheses. So we are forced to do the distributive property because we cannot legally do the order of operations. So I'd have negative 2x, negative 2 times negative 3, positive 6, plus 4 equals 16. Before you move anything, please, oh please, combine like terms on the same side. So you would get negative 2x plus these two together, 10 equals 16. Subtract that 10 over. Negative 2x equals a positive 6. Divide by negative 2. So x is negative 3. Number 12, it looks like we have variables on both sides again, but we are not simplified yet. So before I move anything, let's distribute and simplify. 3 times negative 2, negative 6. 3 times negative 3x, negative 9x, equals another negative 9x minus 4. If my goal is to still get the variables together on the left side, I'm going to add 9x on both sides, but some of you might remember strangely that these combine to be 0 and these combine to be 0, so we're left with negative 6 on one side equals negative 4 on the other. Now this statement that I have left, negative 6 does not equal negative 4, so this statement is absolutely false, which means that no x value can possibly work. So that means that my answer is no solution, and you could write it out as no solution, or you could write it as the null set symbol, an O with a line through it. Number 13, let me combine like terms over here before I move anything. So negative 4x plus 3 equals 5x minus 1x. These variables are on the same side of the equation, so we can combine them to be a 4x plus 19. Now be careful this time. If I want to move this over to the left, I am subtracting 4x. And I know it's really tempting because of this previous problem to say that both the 4x's cross out, but please notice that they do cross out here, but negative 4 and negative 4 is not 0, it is a negative 8x. So our answer is not going to be unusual. If I keep solving, I would subtract 3. Negative 8x equals 16. Divide by negative 8. So x looks like it is negative 2. That is a weird 2. Let me erase that. There we go. Number 14. Now, 2 dreaded things in this problem. 1, please don't forget that there really is a negative 1 in front of this parenthesis. And yes, we do have a fraction here, but please remember that when you see times 1/2, that is the same thing as dividing by 2. If you saw 1/3 here, that would be the same as dividing by 3. If you saw 1/4 is the same as dividing by 4, and so on. So let's simplify. On this side, we are not distributing the 15. We are combining that later. We are distributing the negative 1. And on this side, we are distributing the 1/2. So here, if we bring down the 15, negative 1 times n is negative 1n. Negative 1 times positive 7 is negative 7 equals. Now, I could write out the work the long way, but if you think about that it's dividing by 2, 1/2 of 10 is 5n. 1/2 of negative 32 is a negative 16. So if I look at both sides, I notice that this side has some like terms that I can combine together. So I would have negative 1n left on this side, and 15 minus 7, or positive 8, equals 5n minus 16. Variables on both sides. So now I would, or what I like to do is move the variables to the left, cancel out. Negative 1 and negative 5 is negative 6n. Plus 8 equals, remember, carry this down, is negative 16. Subtract your 8 from both sides. Negative 6n equals negative 16 minus 8, which is negative 24. Sorry about the lack of room here. If I divide both sides by a negative 6, my final answer would be a positive 4. So guys, at this point, I'm only allowed to make 15-minute videos with this program. So I'm going to pause this one here, and I'm going to start again with numbers 15 all the way to 22 on the second video. Thank you.